Welcome. Life is really fast. If I could have your attention, and if I could just burp. Okay. Um, Thank you all for this wonderful turnout. This is the first of I guess, the 16-17 series. We have all our slots this fall are booked, and several in the spring. So we have a very full schedule. As you may or may not know, some of these are given by students now and again. So if any one or two or three of you want to suggest a lunch forum, talk to me or talk to Leora and we'll get you a date. So do think about that. Those of you who are new to this, this lunch forum, aside from providing a whole lot of lunch, is also about providing a whole lot of food for thought. The faculty, or the people, I should say, that offer them often will do this halfway through, should we say, preparation for a conference paper. It's usually a subject that they're not completely worked through about, or that they haven't given before, and we're like a focus group, and we generally have very, very fine discussions. The only thing I would ask is that you don't leave the room until 1 o'clock, because if people start leaving before that, it disrupts everything. And then those of you who want to stay behind a little longer, there's usually a smaller session that'll go on for another 20 minutes or so for more intimate discussion. So, and the speakers are asked to speak for up to 40 minutes, so that there's enough time for back and forth afterwards. I'm going to assume that most of you know Benjamin, but you might not know some of his background. He graduated from the Autonomous National University in Mexico, and he holds degrees in historic building conservation from the Carolina Foundation and the University of Alcalá de Henares in Spain. Here, his research has involved ancient masonry techniques, descriptive geometry, such as we use, but possibly such as were used many hundreds of years ago in both Europe and the Americas. His research has been widely awarded. He participated in a project I don't know about, the tile vaults at the Architectural Biennale in Venice, which is terrific. And if you've taken his studios or seen his studios, he always picks just wonderful projects involving not just preservation, but adaptive reuse, and the combination of new construction and old construction in the spirit of both new and the old. I think of Benjamin as very much a Renaissance man, almost literally, and welcome to the
All right, so I think I'm on time for most of the time. Well, thank you, Michael, for the kind introduction. And, thank you, everyone, for being here. It's a beautiful day outside, so spending your lunch break here with us is definitely an honor. For this talk, what I have prepared is a subject that I have been working on for a number of years. And as Michael mentioned, is something that I have already presented, but I feel that it's still on the works. There are very different things that need to be figured out. Definitely, when I presented it before, it was also under those lines of understanding that it's not completely done. But also, what it proposes is the strong connection that exists in this type of structures. I'm going to talk about specifically about the Guastavino's Brooklyn municipal building vaults, because I think they are important, but also because there is a strong relationship between what is geometry, gravity, structural work, masonry, and so forth. So for the first half of the talk, I'm going to try to make a case for it, and for the second half, trying to get you to understand why is this relevant, and for the second one, I'll try to explain where the research is at this point. So vaults, as we know them, right? I'm not talking about vaults that keep money on the basement of the banks, right? I have been put at pay when I talk about vaults. Once I was in an archaeology session because they thought I was talking about vaults where people were buried, for instance. Right? We're talking about vaults. Vaults are these structural and architectural elements that form space. For instance, these ones that are in a 17th century monastery in Mexico. I have been closely involved with the work of vaults. These are some models for that I did earlier. This is me, right, back in the old times when I was even more beautiful. Right? Don't laugh, guys. I'm serious. So, since the very beginning of my career, I have been involved with vaults, constructing vaults. It's a restoration of a 17th century building in which we were pretty much hands-on doing vault construction using exactly the same technology as it was used 500, 400, I would say 2,000 years ago. These are vaults that you can clearly compare with vaults that were built in the Roman buildings, right? So this experience profoundly made an impact in my life, the way I understand architecture and the interest that I have as a scholar now. So these are the same monastery. We built hundreds of vaults, all of them using traditional technologies. I also had the opportunity to work on a restoration project where we actually rebuilt rift vault. A rift vault that had to do with, or is strongly connected with Gothic methods of construction, all of those carved in stone, right, and forming a structure that is extremely heavy and but actually supports itself just because of its own weight, right? Because the shape of the pieces themselves. So going back about 800 years ago and understanding how these structures were made, actually making one, right? At that point, I was living almost in this, it's an open chapel, it's a church, and people even believed that I was the priest, right, the local priest in town. Sometimes people wanted to come and ask me if I could confess them. Of course, I didn't do it. So anyway, so this is the final result, right? So actually going back in time. So of course, as you can tell, this has made an impact in my life, in my professional development, in the way I understand architecture, as I said. And every time, everywhere I go, I'm always looking up, right? I'm always looking at vaults. I'm always drawing vaults. I always try to understand how they are built. Why is it that they have this presence, this geometry, this, you know, materials, right? Irregular vaults, regular vaults, Islamic vaults, oval vaults, right? Rift vaults everywhere. Historic buildings is a very prominent type of technology that was used in many buildings, mostly in religious buildings. And we can see a variety of them, mostly in Europe, but there are also several of them here in the Americas, right? This one in the cathedral in Murcia for a chapel for a king, so it's a tomb for a king, right? A beautiful one. Right, wood-made works for the Islamic architecture in southern Spain. Right, this one that is a theoretical surface. What is really interesting about this type of structures is the strong relationship that they have between geometry, gravity, and the space itself. When we understand that the implications, construction implications that this type of geometries have, well, we start getting a little bit more involved, a little bit more fascinated by this type of structures. This is specific, for instance, right, because it's an oval. When you cut a section in this direction, right, the section is going to be shorter, of course, than in this direction. And if you start thinking of about this vault in terms of bossoirs, in terms of pieces that actually form those arches, the size of the pieces will be smaller here than they will be over here. And then we're starting to understand how they are actually built. I mean, it's a complex problem. In this one, there is a vertical surface, like a section of a donut, right? That has been taken and made out of stone. So also has different implications. And the stereotomy, which is the science of cutting solids, just you guys learn a lot about stereotomic versus tectonic, right? Stereotomy is actually a science that actually has to do with study of how stone pieces are cut in order to form self-supporting structures, right? So I have seen all types of walls, right? Growing walls, right, made of stone, combination with brick and stone themselves, right? Different types of solutions for the same problem. Bolts that curve, right? Bolts that are flat, right? Like this one on the Escorial in Spain. It's totally flat, doesn't have, well, it has a little bit of a curvature here, but this one is totally flat. How is it that that works? How is it that all those pieces of stone are cut? So there is no reinforcement, there is no rebar, there is nothing that is working in tension. It's purely working in compression. And I find that fascinating. These are other types of faults, right? Following the spiral for the type of the pieces that form the bolts themselves, the bossoirs, right? Making it even more complex, right, and playful, if you will, in terms of whomever designed these bolts, right? And bolts that do not exist. These are actually decoration on walls, right? That they have no depth. Actually, they are just trying to show that. So why volts, right? Why this interest in volts? As I have been mentioning, this relationship between form, between geometry and structure. Working purely in compression, that I find them a fascinating type of structures, and I think that they have a lot of potential in terms of revealing how the material world works. And also, as one of the students told me here, right, it's because they dance with gravity, right? Most of the structures that we see nowadays, the way we think architecture, are structures that are trying to defy gravity. These ones use gravity for their own advantage, right? So they are very intuitive, and therefore they offer extremely good lessons. So this is one of those just the principles that govern those type of course. And Gaudí was very interested in this type of structural work, and he mastered it with all these models that he made. In this case, for the Gaudí family chapel, right? So that has unfolded this interest also into a pedagogical experience, right? Teaching students and professionals from all different universities and fields around the country how to build this type of structures using what is called tile bolts. We are going to be looking at a specific type of bolts, tile bolts, and I want you to pay special attention to the methodology that we are using here. When we have tiles, we have some formwork that is actually guiding the shape, but in fact, the process of construction doesn't involve any supporting materials, right? We have done all this also here with my past construction class 1 year ago, and workshops that I teach that are related to this type of logic, this type of structures, right? So this one, for instance, involves zero formwork, right? And this is all of us over here on top of that. And that also have unfolded into what Michael mentioned. This is the exhibition where I was part of. Some of you were there, and saw the Beyond Bending in the Biennale in Venice, right, where we was involved in the design and the construction of these bolts that are actually presenting an alternative technology, especially for developing countries, where this type of bolts can offer a technology that can be adopted and is sustainable. So this is part of the images at the Biennale. So this also a passion for bolts, right? Is that I actually have been looking also at the work of Felix Candela, There's going to be an exhibition here coming late October on the work of Felix Candela. And my colleague, Juan Ignacio del Cueto, the exhibition that you will see here was actually in Columbia, in New York, right? So I've been fascinated for this type of structures. I said, well, as my colleague from Mexico, he's going to be in New York. I would like to support him and also see the exhibition. So I ended up buying a couple of tickets and convincing my wife that we will get there, see the exhibition, and after seeing the exhibition, we will have a romantic trip in New York, right? So, well, we were actually, going after the exhibition and all those, and the symposium and all of that. Said, well, let's go to a restaurant, right? So the Oyster Bar, right? In the train station in New York, right? So this is my wife, Sarah, right? And she kind of realized that I was being tricky. That yes, it was kind of romantic, but there were boats up there, and they were actually catching my attention a little bit more than their conversation. So she said, you know what, my love, I love you very much. I love your passion for boats. I really support you. But let's do something that is not boats oriented. And I was like, yes, you are right. What do you want? She said, well, I want to go to see the Brooklyn. And I said, well, okay, that sounds fantastic. Let's do that. How do we get there? And she's like, well, subway. And I said, good. All right, subway is a good idea. So what happened, and I swear, what happens that as soon as I'm walking out from Brooklyn subway station, I find this. Well, you are laughing, but my wife didn't laugh. She was like, seriously? Right? So, well, and of course, I started salivating, right, and looking up, and then saying, well, just four more photographs, please, just okay, let's do that. But I found these books especially fascinating because of their geometry, right? These are Guastavinos, and by the way, Rafael Guastavino is a contractor who came from Spain, late 1800s. He built half of fire-resistant structures in New York. A lot of buildings in New York, especially on the East Coast, and all over the United States have Guastavino structures, and as well as the ones that we saw before from the Oysters Bar, right? But I found them really, really fascinating. And believe me, I have seen a lot of books, right? I mean, I'll show you some photographs and I can show you thousands of them. But this has something special. And I think that relied on the fact that they were very, very organic, right? The geometry was so complex. They were almost as, designed by a contemporary architect, right? That is focused on form finding. But these were built in 1910, 1913, right? So this notion of form finding that we have now in design, it wasn't precisely what was driving the solution for these structures. So I was fascinated by the shape, by the freedom that they had, by the complexity. When you start to understand how things are built, you say this is not common, right? And I started to try to, you see these lunettes that have these intersections and all of this happening all over the place. And I was like, what is it that makes this boat so unique? So I was like, I took a bunch of photographs, right? While my wife was waiting for me. That, by the way, it cost me a big dinner later in the evening, right? But I mean, turned out that I, collected some information, and I went back and I started looking at them just with my camera, taking photographs, and then understanding. First of all, the plan of the building. This is the municipal building in New York. McKeith, Bed and White, as I said, is mid 1910s, right? 15, 13, something like that. And McKeith, Bed and White worked a lot with Guastavino. And they had a lot of work with him because of his fireproofing system, which was made with these tile bolts that we were talking about. And then, well, looking at the plan, right, I realized that, well, the plan has a specific configuration, and then I go to the Avery library, collect the actual Guastavino drawings. These are his drawings for this project, and started to see that the way the configuration of the columns is pretty irregular. First of all, because of the shape of the building itself, and secondly, because of the subway going underground. So when building this building, this was one of the tallest buildings of the world at the time, and they had to find ways in which they could connect the vertical supports, the columns, right, to the foundation and the rock underneath without actually interfering with the subway. That created this, what I call these unusual conditions, right, where all the distances between columns are not even, right? There are very few bays that are actually regular, but in fact, all of them are in fact, everything is very regular. So generally speaking, if you look at McKim, Med, and White's drawings, when they hire Guastavino, they will have a plan. They will not specify anything. They will just write Guastavino here. Right? And it was him as a contractor, in charge of actually creating these drawings and figuring out what solution for these structures. So looking at these drawings with more detail, we see that they have some sections drawn, right? So a section here and a section here. And this first section, right, is quite interesting because it follows this line on the plan, right? It's not precisely a straight section. And what is revealing, right, is half of one bolt, half of a different bolt, all the bolts going, all of them going through right to the crown of the bolt, meaning the highest point itself. And then start revealing what the details of these geometries are, right? And first of all, you realize that, well, Guastavino had, in addition to these very unusual conditions, he had some restrictions. For design reasons, this is something that I haven't really found out yet, it's just an assumption, right? For design reasons, what he had as the space that he had between the capital of the columns and the intermediate floor, which I am assuming is a steel construction, right? What he had was 2.7, right? So that was what he had. And within that space, he had to develop all this structure. And as I said, the point was to have this layer that is fire resistant, right? That will protect the structure above. And in addition, provide this beautiful space, of course, right? So we start seeing that. So then, we're seeing details such as, well, so Guastavino saying this is now a straight section through this, right? Through those, what is called former arches, showing them through the crown of the bolt and saying true ellipse, right? True ellipse. So that also makes it interesting because we're also seeing here that semicircular arches are governing the geometry, and simultaneously true ellipses are supposed to be governing the geometry. So the very first question is, really true ellipses? And the reason why you ask really true ellipses is because by tradition, ellipses were not common in the construction of arches. Because in order to draw an ellipse, you need a series of procedures, geometrical procedures that are somehow complicated, right? If you want to draw an ellipse, you need two foci, right, generally speaking, and then once you find those foci, you can actually draw an ellipse. Or there are some other methods that, if you want to learn, I will be happy to teach you, like this one, right, by finding different points, by a parallelepiped that surrounds the long axis, the short axis, and the long axis of the ellipse, and then you find points, and by approximation, you build an ellipse. But what is much more precise is what is called the basket arch. This is the model of the basket arch, which forms almost an elliptical shape, but with arches or segments of arcs that are tangent to each other, right? And that was more very common within masons because you can control that much more than drawing an ellipse. They are segments of circles. You can find the circle, the center of the circle, and the center of the circle here, and then draw a continuous line that pretty much is very similar to the ellipse. So the question here is, was Tabino understood the idea of an ellipse, right? Was that actually an ellipse or not? So I started to draw, right, both. What you see in blue are the ellipses, right? And what you see in red are the basket arches. So you can see the circles that are involved here, for instance, this circle and these other two circles are tangent to each other and form the almost elliptical line. So in fact, when taking a closer look, you realize that even the drawings don't follow an ellipse. They actually follow a basket arch, right? Because that was the way they drew it, right? That was the way they would understand it. So by saying true ellipse, I think Davino was referring to the basket arch, but in reality, we don't know exactly what he meant by that. But we can see that look at how close the curves are to each other, but in reality, they are, yes.
Right. He specified the spring line
Yeah,
as higher than the crowns of the columns. And when you drew your ellipse, you took the spring line to be along the line of the column.
you mean it here?
Yeah, on his drawing it says spring line.
Over here.
Yeah.
Yeah.
So that was common in classical architecture to start the arch
above
the column.
the column. Yes, there is a straight line over here. There is a straight line. And it's much more evident when you have semicircular arches.
Right.
But it's not as evident when you start seeing these arches themselves.
Yeah.
But it's true. It's true. It's another aspect to consider, right? So we go back to these irregular conditions, right? And then, okay, so what's the solution here? How do we find the solution? And I start, well, realizing that if you divide each one of the base, right, you get a shape like irregular, right? And therefore you can actually form 10 different volts, which with their own set of rules, with their own set of geometries happening within the roof itself. And then let's go back to again to historic architecture, historic methods of construction, right? When you look at the different treatises and the different stereotomy documents of people who have been doing this, or were doing that in 17th century, 16th century, 15th century, you realize that the notion of an irregular plan, this is Joseph Gelabert, 17th century master builder in the area that is now Catalonia, right? Within his manuscript, he actually talks about the solution of an irregular plan vault, which was a very common problem in late Gothic architecture, right? We are seeing here Pilet also looking at pieces of stone, right, of an irregular element. Perhaps this would be a flight of a stair or something, right? And how what starts as a circle ends up as an ellipse, and therefore the distortions that perhaps the piece of stone need to take in order to adjust to that. So there is a number of treatises and problems that emerge, right, from the notion of an irregular plan. For instance, here, right, if we have a sphere and we cut the sphere on vertically or with an irregular polygon, each one of the arches is going to be different, right? Each one of the arcs are going to be different. And the consequences of those is that some are higher and some are lower, right? And in a space that is covered by a sphere and is configured by this type of polygon, that's going to be special consequences because some walls or some windows or some doors will be taller than others, right? And so all of that is what people who were concerned about this type of problems were dealing with. And then one of the original drawings that from Alonso de Vandelvira, 16th century manuscript in Spain, which dedicates an entire chapter of this. The manuscript shows how to build a growing board, how to build a skew arch, all these very particular cases of stereotomy and arches, based on arches, right, and vaults, and dedicates an entire chapter, obviously, to irregular plan vaults, right? Because that was a challenge, especially if you think about constructing them with stone only, or with masonry, with pieces of stone, and the geometrical implications. So he starts speculating about how this can be solved, especially looking at one single surface. But he starts the chapter by looking at the first solution using ribbed vaults. In other words, identifying the area where different surfaces can intersect with each other, and then be able to provide the solution for an irregular plan vault, right? He then keeps speculating, and then at the end is showing, okay, how would I do this with a single surface, right? Surface that will be warped, a surface that will not be governed by a very clear geometry, but its origin is on ribbed walls and finding the lines that actually govern the geometry itself. When you look at Gothic walls, and the origin of the rib is mostly to control the geometry, right? That's one of the main functions of the rib. So it's a Renaissance master builder who goes back to the Gothic methods of construction in order to find the solution for a contemporary problem. And when we look at Guastavino's problem, we start realizing that it has a lot of things in common with the problem that Vandelvira proposed, right? So the very first thing after those photographs that I took, right, is to insert those photographs into a photogrammetry software that will help to identify several points, and it was relatively easy here with all these reference points that the masonry itself offers, in order to start reconstructing surfaces within the digital environment. So referring points to each other, and then start looking at what actually governs this geometry, start looking at modeling, right, in order to identify what the main issues are here, right? And then, well, realizing that in order to understand how each one of these vaults is built or understood from the geometric point of view, it's necessary to pretty much make sections through each one of those arches. And as you start making sections through each one of those arches that govern the geometry of all the vaults, right, you start realizing that, in fact, what happens is that Guastavino, what he controlled pretty much was the intersection of the surfaces, but the surfaces in between were pretty much a consequence of this initial geometry. Does it make sense? Yes? No? Mm-hmm. Yeah? Más o menos? Okay. So in other words, right, what he's controlling is this rib, right? Is this intersection between this surface and this surface, right? In this case, for instance, it will be an elliptical or basket arch, straight barrel bolt, right? That intersects with this surface, right? But guess what? Right? An ellipse, the equation of an ellipse is an equation of second grade. So when you connect two ellipses together, the curve that they define is not a straight curve, right? That's why also he had to control the seam between the two surfaces, and this was also pre-defined. So what governs the geometry is this arch and this connection, and what happens here is what the mason wanted, right, to happen, what the final solution would be. So that is at the end what is actually going here, going on here, and in all these different areas, right, we see this intersection between this surface and this surface and these surfaces here. Then two variables intersecting each other would be, when you look at these intersections in plan, they define straight lines, right? They are straight lines in Guastavino's solution, right? Therefore, two ellipses intersecting each other, especially even if they have, right, different widths, right, will be very, very, very difficult to control. So controlling this was the secret. And also having, of course, a very skillful set of masons, right, who were able to identify. That's why, right, you can see that these are marked originally, right, and the surfaces connecting each other work that way, right? So keep doing this analysis, will confirm this. I'm in the process actually to getting nicer drawings as part, right? Because these are kind of preliminary, different ways of looking at how this could be represented. So that's also part of the questions that I think will emerge from this body of research, right? And of course, looking at how in the process, like how these were built by the necessity, or with the necessity of controlling that rib, that intersection, the groin where the two surfaces converge, right? Then looking at ways in which some of the formwork, as I showed you before from the ones that I have built with students, right? Some of the formwork will have to be built so that the geometry is controlled, right? In order to come up to these results. So at the end, right, but also what is interesting, what I found interesting learning here is that Guastavino went back similarly to what Vandelvira did, right? Went back to Gothic methods of construction. And if you think about these vaults, right, you can even propose that these are one of the latest Gothic vaults that were built, right? Because they follow exactly the logic that Gothic master builders used in those historic buildings. And with this, I conclude, and thank you very much.
Go to the Gustavino's afterwards? There's a fancy restaurant called Gustavino's under the
Yeah.
59th Street Bridge.
Yes, no, I haven't been there.
I just thought
Next
you could have
time.
taken your wife there.
Sorry, yeah, probably not too much.
Can you say something about how thick those tiles are?
Yeah,
Those tiles are structural, not decorative, right?
no, they are structural, yes. They are structural, and they are about, well, they vary, but they are about a half of an inch or 3/4 of an inch thick. And generally speaking, what was to
And
be
that's it. It's just that, and then there's air.
two layers.
Two layers.
Two layers, right? Two layers. One that has this glass finish, the one that we can see here, and another one that is rougher, that is less finished.
So total thickness is maybe 3 inches.
Yeah, something like that. Yeah.
The image that you had of your students making it somewhere, it looked like the tiles were not, they weren't like in a running bond. It looked like they were laying one on top of another. Is that how you? Maybe they're not staggered the way you do a running bond.
Let's go back.
There's a lot. The beginning.
Yeah. I will say that what we see here from on these vaults, it's the finish is a lot more carefully, or the surface that we see is a lot more carefully made, right? We can see very precise.
That's laid first.
But that's laid first, isn't it?
That's a very good question. That's another question that we all have. I mean, even this group that I've been working also so we don't really know. Well, when we see, we are talking about this, right?
I think it was on you had some slide where they were making it. This
Okay.
one.
This one is a replica of the dome.
Yeah, this one.
This one.
Yeah.
Oh, sorry. Here, right?
Yeah.
So, this that this the intention was for students to learn about how you build this, right? But the there are different ways of addressing this, right? One will be to make arches that are from parallel to each other, understanding that the arches are going to be also always working in this direction, right? And then growing is going to be where the two arches converge and then transfer the load towards the support. This is a very, of course, it's a very sloppy process at this point, but you can see how the arches, right? The logic is right, an arch here, another arch here, another arch here, and then perpendicular to that arch, right? And then point where they both converge is forms that growing.
I guess my question was that I had thought, I mean, I know very little about how tile vaults are made, but I had thought that they would stagger one tile from another just simply by the geometry. It would start to stagger, but it just
The joints wouldn't line up.
They wouldn't line up. But
Okay.
when you build a second layer, this second layer over here, we don't have photographs here, but this second layer, you make sure that the joints do not line up vertically, right?
Maybe it should look like they did it.
But this is a little bit thinner, but this is about how the size of how, in proportions, how the relationship between how thick and the span is. And in this case, we couldn't fit any more students. We couldn't.
Let's have some questions from students.
I'm a student of life.
Okay, let's have some questions from older students.
Okay, older students.
Yes.
So
okay.
can you get into the cavity between the two?
Yeah.
Have you?
That's part of the things that I need to still find out. I mean, in my hypothesis is that yes, you can. That is just open space between the vault and the actual intermediate floor
Because it's
structure.
all it is fire cladding, right? Fire
All
cladding.
of it is fire cladding. It's
Self-supporting, but not
self-supporting, but not supporting anything. Yeah.
What are your thoughts on the light fixtures?
The light fixtures.
Yeah.
The ones that they install.
Like in terms of the placement,
Yeah.
some are more successful than others.
Than others. It's always a challenge with this type of structure. For instance, here, right on Candelas, right? It's a very nice space, but the lights. I mean,
I thought the Oyster Bar did a great job.
yeah, with all this. This one, right?
Yeah.
Highlighting the arches, but obviously this is an actor, but this is the original one. And right, like the keystone, right? Yeah. Yeah, I mean, it's always challenging. Generally speaking, if someone will be doing this nowadays, probably will have light coming from the spring line, so to enhance the curvature, right? The geometry.
What always calls my attention is this encounter of some European knowledge with the American fabricators. In the case of the Oaxaca chapels, the open chapels, the Postcolula, etc., it's very clear. There were European orders, and the locals had to build it.
Yeah.
And that encounter was right there. In the case of Gustavino, which is already 100 years after independence, or a little more,
Yeah.
I still see a little bit of a difference there. When he crossed the ocean, something changes. And I suspect, and I want to bounce that off of you, is that there's a geometry freedom in those buildings that we don't find in Europe. And I might be wrong. But all this complexity of this plan, I don't find it in Europe, not at that time.
No, and as I mentioned, I mean, the origin of that is mostly, I think, the software underneath, right? And the shape that the building designed by Makin White with this kind of U shape. But generally speaking, if Pastorino did a lot of work and when he was mostly in charge, he would aim for a symmetrical, more regular type of construction because it's more predictable structurally, right? I mean, the advances of, for instance, what Philippe Bloch, Oxendorf, and de Jong did for this stone vault at the Biennale. I only participated on the traditional tile vaults, right? It's pretty much the merit is that to find form that also works asymmetrical with asymmetrical loads and supports itself. So they will have the tendency to think symmetrically. In this case, it was impossible, right? And yeah, it evolved into something different that you don't find.
I also want to get to the point that symmetrical is easier. Like symmetrical is more predictable, easier, less risky. The real invention is on working all those trapezoids into the vaults. That's where the real skill is needed.
Yeah.
Do you see variation along Guastavino's career in the tiles themselves, or was he using really the same module and his geometries got more complex?
Yeah, Guastavino, when he started his company, he started to also make the tiles, and the tiles will be specific to the job.
Oh, okay.
So he will build larger tiles for larger commissions. For instance, St. John's the Divine, New York is a very large dome, so the tiles there will be larger because you would go faster, but also because you will build faster, but also because they will probably get more structural strength. So yes, they were job specific. So he was a fabricator of his own material, and he will match it with the type of commission he had. Now I want to make clear that this type of work, right, is very unusual in Guastavino. He wasn't interested in making something form fancy. I mean, it wasn't his aim. It was just a solution for a very specific problem and with a very specific context, and you don't see it that often. So it wasn't the master builder who was thinking, like, let's do something more complex. Perhaps the complexity for him would have been the span. How to actually get something that is wider and wider and wider and wider, right?
And then the other question with that is, were other people speccing Guastavino tiles for other things?
For other architects expecting for other things such as
for vaults that other people designed using his tiles though, or was it his vaults, his tiles? And
he patented this. So if you wanted a fireproofing Guastavino vault, you had to hire Guastavino's company.
It was a construction company.
Yeah, construction company. Yeah.
Have you found contemporary reactions to this when it opened?
Contemporary reactions.
Like for when the subway station opened, have you found like accounts of it opened and like the responses that people? Because I don't know New York subway system at all, but this seems very monumental even today. So
that's the part of the research that I have not completed. Right now, I'm trying to find funding. If you guys want to help me, there is a basket outside for my plane ticket, so I can go to the. I'm interested in the contractual context between McKinney and White, also with the general contractor. But it would be interesting also to find out if there was any specific response to the users when this was open to the public. That's another layer. Yeah.
So what's fascinating to me is that, from what I gathered from your lecture, it was the architects controlled for a couple key sections, and they were simply contractor figure it out.
Yeah.
But I mean, to the degree that we do that today, it's never a lot of those seams that you're getting in the form is basically we'll take whatever you can get, fabricator.
Yeah.
So is there that's amazing to me, one, that the architects have so much confidence in that sort of arrangement, and two, is there any sort of spiritual success to that, like presently? I feel like it's very rare, just something so prominent to be like, okay, we're gonna do this, and contractor, you figure it out, and whatever we get, you know. I'm wondering if there's anyone actually, is there a spiritual successor to that sort of design?
I think it happens very, very, very rarely today.
Yeah.
Architects do more and more and more drawings of absolutely everything, maybe triple, quadruple the number of drawings
And this
that were
formality-
once made. Yeah, buildings were once, the number of drawings, like to build Battle Hall, was probably like 100 sheets max, or even less. Today it would be several hundred. Because you would be able to just leave things to a certain point and have the contractor produce shop drawings. They had their own people who would take it to the end.
Is design built, or the subcontractors
Yeah.
would, I mean, it happens a lot still, but certainly less and less.
It's less and less, right?
But if you look at our urban partners, that's what they do. They provide those very specific services to the star architects,
Right.
and they.
But there was like an attitude of, like they couldn't, this stuff for today, we would model that in Rhino immediately. We would take two, extrude a loft surface, find the intersections. I think it's just remarkable. It's not really a question, it's just, that's freaking amazing.
Yeah, but the interesting part is that the assumption is that you have the surfaces and then you find the intersection. If you do that, that's what I wanted to also communicate here. You don't get a straight line. You will get a wobbly line. So therefore, you need first to draw this, and what happens between this and this, these two, and the
Right,
other
there are
ones.
probably slight bends in there,
Yes,
so that it comes out
But
straight.
how did you do the structural analysis on that, or was there no structural?
Well,
There wasn't any. I'm sure.
there was he was.
It's just a surface.
He just knew.
It was
There was also a
empirical.
little bit of just,
It was empirical.
And if it didn't fall down in the first week, it wasn't going to fall down.
He used graphic statics. And you see some of these drawings from his office using graphic statics too. But mostly for large commissions. I think that he also has a document that he published about the cohesive construction, and that he claims that it's pretty much after the motor settles, they became monolithical. But even his own son, who was very involved in many of these solutions, will say that I'm not so much, right? There is some compression here. There are some areas that are under a lot of stress. It's not precisely monolithic.
Does the firm exist today?
No, they died around 1980s, right? 1970s, 1980s.
So, Benjamin, do you have an intuition about like the consequences on the structural integrity of the thing from all of its eccentricities? I mean, you work with, I know you haven't done a structural analysis, but they have a lot of freedom because it is literally just a fire barrier and a decorative surface.
Yeah.
And it's not like the vaults that you were showing with you and your students standing on it.
Mm-hmm.
But intuitively, I just wonder if you have an intuition about like what the consequence would be of thinking of these things more than just as.
Well, I mean, intuitively, I think that because of the height of the building, right, and all the weight that they have on top of that, I think the thrust of these bolts will have, if that's the question, will have minimum impact on the overall
No, I just meant
structure.
a shape of this kind. If all of the eccentricities.
Okay, within themselves.
If you were thinking of it more in a
Yeah,
sense that
no,
would have
I
structural
don't.
integrity.
I don't, and I think that will be another layer of this research to actually take one and say, okay, based on these conditions, how is it that these arches are pushing, and how is it that it's actually working because of the lack of symmetry that we were talking about. Yeah, that's a good point.
Question at the back. Yeah.
Yes, is this kind of masonry, is it highly skilled, as in if you wanted to build a vault today in your house, which maybe you have already, but if you wanted to do that, would you have to find someone who specialized in vaults, or could this be kind of intuitive for any mason? Is it kind of a dying skill?
It's I mean, my experience is that I have trained people for 1 week on building it, and then they feel confident to actually build it. And they are not necessarily skilled masons. Skilled masons, of course, pick it up faster and much better, understand better, right? But yeah, it's not precisely something that is reserved for someone who has already skills. I think anyone can learn it, as you can see, could see.
We did it in like a couple weeks in the construction class, and none of us were skilled masons in any stretch of the imagination. So
Yeah.
Were these done with formwork? Do you know?
what I propose is that, you know, and I need to learn more, but what I'm proposing, my hypothesis is the form work was just to control these arches.
Like
the
you did
geometry.
yours, so
Yeah.
they were all kind of corbelled out rather
Yeah.
than.
Are there any construction photos in the archive?
I haven't seen it. That's another question that I have. You know, I went to the Guastavinos, right, and I found the drawings, but I haven't seen photographs. Perhaps McKinley and White also archives will have some. So that's the other. That's where I am right now. So I took I'm starting here, but I know there are some other layers that unfold from this.
Well, I don't have quite the last word. Back to the board, yes.
There's a sort of parallel here between quite a unfortunate example, but during the apartheid years in South Africa, some of the first social housing architects from the city came up with a sort of idea it was a sort of economic plan where skilled architects would build some of the frame of the social housing. They were called RDP, which is research. I don't know what it stands for, but basically it was social housing for these really large locations, and so the skilled workers would come and build almost these triangular frames, and then labourers would fill in the rest, and that was kind of a strategy to keep the costs of the social housing down. Michael probably knows about it.
A little bit.
So I was wondering whether this kind of, not the overall goal, but one of the points on your agenda is to think about this as kind of sustainable, economically efficient, low-tech form of construction for developing countries.
Yes.
Is that kind of the direction?
That's part of it. Yes, I mean that's how they were presented at the Biennale. And when we were making the mock-ups, we were also always thinking, okay, we need to make it clear enough so, first of all, that people understand that we understand what we are doing, right? But second, that if someone comes to the exhibition and says, I would like to do that, they understand how, and then they can actually replicate it in their own. We did some with actually rammed earth, like with small adobes, right? And I think that's where we are trying to push it now for experimenting with the structural strength or the compressive strength of that material is relatively questionable, right? Yeah. So that's where the challenge is, but it will be just making little adobes from the ground and actually be able to build your own roofs.
I think Peter Rich.
Yes, he did one. Yes, exactly. And that's also the Block and Oxenberg were involved in that. I wasn't even around. Yeah.
Peter Rich was in my class.
He was my professor in Johannesburg.
He was?
Yeah, they did. And that's what they did. That's what they did there, right? Yeah, very similar. That's kind of the underlying logic behind it.
The only thing that I'm turning over in my mind is that you started your lecture with pictures of vaults from churches. And it seems like the ambition of those vaults is different to the ambition of these vaults. And that you sort of carried the water, so to speak, between those two manifestations by saying that architecture was about gravity, light, and structure and construction. Well, if architecture is about that, then this is about that. So this is about those churches. But I think the people who built the church vaults and who created those shells of light with patterns of structure were not looking for structural expression at all. I don't think they thought architecture was about structure and light.
What do you think they thought they were?
Well, that was a vision of heaven. That was a vision of angels.
Yeah.
It was the kind of thing they would sometimes paint on the ceilings, except here it was in light and stone. Yeah. And the improbability of the shapes and the fact that they could be like brocades was somehow the point. Yeah. I think it's a very modern view to look at that and go, yeah, all that frou-frou stuff. This is the real stuff. They really were interested in structure and light. And that actually is just a modernist trope. It's like sucking the juice out of that and just saying we'll use this.
Well, yeah, I mean, it's an argument that can be made, And on the other hand, as you see some of the solutions for especially late Renaissance structures, you can see that the builder, the master builder, was really aiming to make a statement on how skillful and how this was about structure and light. For instance, this one. Why to make it spiral?
Exactly.
There is no logic, right, besides showing off.
Okay, I'm going to close formally before we go.